Hi everyone, so this video is intended for answering the conceptualized questions that our instructors have given to us. Our subject is biochemistry, so probably the questions or the 10 questions that are given to us is related to biochemistry. So there are 10 questions, so I'll start to number one. So number one question is,
How do monosaccharides produce acidic sugar?
monosaccharides can produce acidic sugar through a process of oxidation. Oxidation is the process where they lose electrons. This typically occurs at the carbonyl group or aldehyde or ketone of the monosaccharide. The oxidation through um, can be carried out by oxidizing agents such as oxygen, hydrogen, and other metal ions. So again, the process of monosaccharides that can produce acidic sugar is oxidation. So now let's proceed to number two.
What are the three acidic sugars that monosaccharides produce? Explain their difference.
So there are three acidic sugar that monosaccharides can produce. So first we have aldoric, second we have aldonic, second we have aldaric, and then third is uronic. So aldonic formed when the aldehyde group of monosaccharide is oxidized. So in aldaric, it is formed when both the aldehyde and the secondary group of monosaccharides are oxidized. In uronic, it is formed when the primary group of monosaccharide, primary alcohol group of monosaccharide is oxidized. This occurs mainly in hexoses. So the answer of number two are the aldonic, aldaric, and uronic. So let us proceed to number three.
What is the process involved for the monosaccharides to produce sugar alcohol, and what catalyst is involved?
So the process of monosaccharides to produce sugar alcohol, or also called as polyols, is called reduction. In this process, the carbonyl group or aldehyde or ketone of the monosaccharide mm, is reduced, gaining electrons and converting to a hydroxyl group. This reaction often involves catalysts such as sodium borohydride and lithium aluminum hydride. So again, the name or the process for monosaccharides to form or to produce sugar alcohol is reduction. So we're done with number three, and let's proceed to number four.
What is the general name for monosaccharide acetals and how did they form?
So the question is, what is the name or the general name for monosaccharides? Acetal, the name for the monosaccharides, a general name for monosaccharide is glycosides. Glycosides is formed when the hemiacetal group of monosaccharide react to an alcohol to form a new acetal group, or to form a kettle or acetal group. So the process, a general name is the glycosides. So number five.
What are oxyacids and how do their reaction with monosaccharides end up to?
So oxyacids are compound containing hydroxyl or and oxygen groups. When oxyacids react with monosaccharides, they can oxidize the carbonyl group of the monosaccharide, leading to the formation of acidic sugar, which are the aldonic, aldaric, and uronic acids. Number six.
Monosaccharides can form amino sugar. Explain how.
So, monosaccharides, yes, it can form amino sugars through a process called amination. So, amination undergo a process um, where an amino group is introduced to the monosaccharide. This reaction typically requires a catalyst and an energy source. The amination process can occur at different positions uh, can occur of different position of monosaccharide leading to various amino sugar. So for example, if the glucosamine and the galactosamine, galactosamine. For example, glucosamine, it is formed when the amino group is introduced at the ceto position of glucose. So, when the amino group is introduced to the position of ceto position of glucose, it can produce glucosamine. So, number 7.
Explain the significance of superimposable and non-superimposable mirror images and the concepts of chirality.
So, when we say non-superimposable and superimposable, superimposable refers to when we say superimposable, it is not chiral. When we say non-superimposable, it is chiral. So those are um, the different, uh, the the meaning of superimposable and impossible in the context of chirality. And also, it is important because in pharmaceutical, or like what Sir Konya have said to us during discussion, that in pharmaceutical, the other compound might be um, effective, but in the other, if the mirror of that certain um, pharmaceutical products will be produced, it might be not as effective as the mirror. Okay, number 8.
Distinguish stereoisomers in enantiomers, diastereomers, empimers,
Epimers and anomers. Okay, here's a brief overview of those mentioned words. So, when we say stereoisomers, it is the molecules with the same molecular formula and connectivity but different arrangement of their atoms. So, when we say enantiomers, it is the stereo isomers that are non-superimposable mirror images of each other. When we say diastereomers, it is a stereoisomers that are not mirror images of each other. So epimers is the diastereomers that differ only in one configuration of one stereocenter. Anomers is the epimers that differ in the configuration at the anomeric carbon. Um, at the anomeric carbon, the carbon involved in the hemiacetal hemiacetal formation. So number 9.
how to determine the handedness of monosaccharide in both Fischer and Howard projection.
So to determine the handedness, D or L, dextro or levo of monosaccharide in Fisker projections, uh, look at the orientation of the hydroxyl group attached to the chiral carbon farthest from the carbonyl group. So if the hydroxyl group is on the right side, the monosaccharide is considered as the dextro or right. So if it's on the left side, the monosaccharide is in the L configuration or level. So in our projection, it is considered alpha if the hydroxyl group and aldehyde is um, opposite, and it is considered as beta if alpha and hydroxyl is aligned. It's either they're both at the top and they're both at the low point. Okay, number 10.
What are the classification of carbohydrates? How are they classified?
So carbohydrates can be classified into the following categories based on their structure and functions. So first we have monosaccharides. Monosaccharides is a simple sugars um, such as glucose, fructose, and ribose that cannot be hydrolyzed into smaller sugar units. So we have oligosaccharides. This is a complex carbohydrates composed of 2 to 10 monosaccharides units joined by glycosides bonds. They can be further classified into disaccharides, trisaccharides, and so on. So next we have polysaccharides. So it is a complex composed of more than 10 monosaccharides units joined. So in oligo, it composed of 2 to 10, but here in polysaccharides, it is more than 10. They can be classified and into homopolysaccharides made of single type of monosaccharides such as starch, cellulose, and glycogen. So, so I hope that the 10 questions are answered through my through this video. So thank you and bye bye.